Alright, so now we're going to cover probably the most important principle that you're ever going to figure out in electronics, something called Ohm's Law. All of our laws, all of our beliefs in electronics, all funnel down to this one law, discovered by a gentleman by the name of Mr. George Ohm. And Ohm's Law is a relationship between the three elements of electronics or electricity: voltage, current, and resistance. So it's a relationship between those three components: voltage, current, and resistance. This relationship can be set out mathematically, saying that the voltage in a circuit is equal to the current times the resistance. So this is a mathematical representation of the relationship in Ohm's law. So voltage is equal to current times resistance. If you remember our discussion from last lecture about what resistance is opposition to current flow. So there's a relationship there. The larger the resistance, the lower the current. So again, remember that bumpy road. More bumpy road, less speed. So therefore, more resistance, less current. So if you give a certain voltage, if you increase the resistance, in order to keep this mathematical equation correct, if you increase the resistance, the current must come down. So there's a mathematical relationship between voltage, current, and resistance. So the basic formula is voltage is equal to current times resistance. We can mathematically arrange that and solve for current is equal to voltage over resistance, or resistance is equal to voltage over current. So there are three formulas, or three arrangements of the formula to figure out, depending on which element you want to solve for. You will see the Ohm's Law triangle. Voltage on top, current and resistance below. This is a little visual reminder on how the formula works. So if you can remember this triangle, what you do is you take your thumb and you cover the component that you want to solve for. So let's say I wanted to solve for resistance. I will take my thumb and cover resistance. Therefore, resistance is equal to voltage over current. If I wanted to solve for voltage, cover voltage, and it's current times resistance. If I want to solve for current, it is voltage over resistance. So this is what's known as the Ohm's Law triangle. It's just a visual representation to help you remember the formula in Ohm's Law. So let's take a basic circuit. One resistor, I'm going to apply 10 volts. And I am going to, that resistor is the one that we are utilizing, and it was 9.9 kilo ohms. So here is that circuit right there. Okay, so this resistor was the 9.9 kilo ohms, supposed to be 10, remember? But, and then I've got my 10 volts attached. So, there's 10 volts across that resistor. According to Ohm's law, I can now calculate the current flowing through that resistor if I have the voltage going across it, so voltage going across it divided by the resistance. So the voltage was 10 volts. The resistance was 9.9 kilo ohms. So therefore, my current is going to be, I bring out my old trusty calculator, 10 volts divided by 9.9 kilo equals, we've got 1.01 milliamps. 1.01 milliamps. And again, you need to get used to the way that your calculator displays values. I've been using this calculator for many years, so I am quite familiar with it. Your calculator will probably display values different, so you must get used to it. So in order to prove Ohm's law, what I'm going to do is I am going to now measure the current flowing in that circuit. So I am going to break the circuit, and I'm going to put my ammeter here to measure the current flowing through that resistor. So the current would leave and it gets counted before it gets to that resistor. So I'm going to break the circuit. I am going to set up my meter to measure current. So again, connect the circuit and reconnect. So I am getting, where's my marker gone to? Here we go. I am getting 0.96 milliamps. That is acceptable within error. So within measurement error. So I'm getting, if I round it off, that would round off to 1 milliamp. If I round it off, that would round off to 1 milliamp. So theoretically, we are getting the same measurement. All right, one more example. So now I've taken, just for a different look, I've taken a 100 ohm resistor. So this is a ceramic style resistor. It can handle more heat, but it's still a resistor, 100 ohms. I still have my same 10 volts. If I did this mathematically now, again, my current would be equal to my voltage divided by my resistance. So in this particular case, current is equal to 10 volts divided by 100 ohms. And if I did my math, so 10 divided by 100, I'm going to get 100 milliamps, approximately 100 milliamps of current. So let's take a look. Again, I'm going to break the circuit. I'm going to put my meter up and count those electrons. Break the circuit. Meter, count the electrons. So I'm counting 99.6 milliamps. So again, that's within measurement error, experimental error. Okay, so I'm going to make a change. Here's the circuit. I have the circuit broken and an amp meter connected. I am going to randomly change the voltage. So remember, the resistor is 100 ohms. I'm going to randomly change the voltage. There we go. I have no idea what the voltage is. So my resistance is 100 ohms. My current is 142.6 milliamps. So my current is 142.6 milliamps. My resistance is 100 ohms. So therefore, my voltage is equal to what? Ohm's law tells me that I take 142.6 milliamps times 100 ohms. So I plug that into my calculator. So I got 142.6 milliamps times 100 ohms. That comes to 14.26 volts. So that's 14.26 volts. So 14.26 volts. According to Ohm's law, I should have 14.26 volts at the power supply. So let's measure it. So I'm just going to disconnect my meter here. So here's my power supply lines. I'm going to set up to measure DC volts. And my power supply is putting out 14.3 volts. 14.33. Again, well within experimental error. Alright, let's do one more. This time we've got resistance. So from my power supply, I have 10 volts. Resistor, I just grabbed a resistor. I have no idea what value it is from my kit. And I'm going to plug it in. I'm going to hook up the power supply. And then I'm going to use Ohm's law to figure out what the value of that resistor is. So I'm going to hook up my 10 volt supply. So now I know that my voltage is 10 volts. I'm going to measure the current. So to measure the current, I set this up for an ammeter, I need to break the circuit so that the electrons can go up and get counted in that ammeter. So I break the circuit, reconnect here, and connect here. So now my current is 2.12 milliamps, let's say. So now, according to Ohm's law, my resistance should be equal to voltage over current, and that is 10 volts divided by 2.12 milliamps. So bring out the old trusty calculator. 10 divided by 2.12 milli, and we end up with 4.716, so 4.72 kilo ohms. 4.72 kilo ohms. So now I'll take a look and see what that resistor actually is. So I'll disconnect this. And this resistor is yellow, violet, red, gold. So yellow, violet, red, gold. So that's 4, 7, 2 zeros plus or minus 5%. So, according to Ohm's law, this calculates out to be 4.72 kilo ohms, and it is supposed to be 4.7 kilo ohms, and that is well within the tolerance of 5%. So, again, Ohm's law, relationship, mathematical relationship between voltage, current, and resistance. So what we covered in today's lecture, electric basics. So remember, we have power supply, a control, safety, and then whatever is doing the work. Circuit measurements. Voltage is measured across a component. Current is measured through a component. And resistance must be measured outside of the circuit. Ohm's law, a relationship between voltage, current, and resistance. And that relationship takes the form of voltage is equal to current times resistance. Again, probably the most important law you will learn in electronics. So all the stuff today comes from our textbook, Principles of Electric Circuits, Chapter 2-6, 2-7, and 3.1 to 3.4. So 2-6, that's the basics of the circuit. Circuit measurements, 2-7, and then Ohm's law and calculations are 3.1 to 3.4. So you can find it in basics. Principles of Electric Circuits, again, conventional current flow edition, Floyd and Buckla 10th edition. Well, I hope this helps. Until next time, everybody stay safe. Take care.